Hi, I'm Steve Tateosian from Infineon. I run the microcontroller product line focused on IoT, consumer, and industrial applications. I'm pleased to be here again this year to talk to the RT-Thread community, and I want to thank you for your time to listen to my presentation. First, let me start with a little bit about Infineon. Infineon is focused on two megatrends, decarbonization and digitalization. What this means from a microcontroller perspective, of course, is how do we make our systems more efficient, that is, use less energy, and how do we make them smarter? So more intelligence, specifically at the edge, which I'm going to talk about more as we go through this presentation, and how do we connect that so that our devices work together in a more intelligent and efficient manner. The intent here, of course, is to make life easier, safer, and greener for all of us. Now, when we look at IoT, of course, where I'm going to be talking today mostly is in this center section here, where we've taken the real world or the analog world on the left with a wide range of end applications, from power supplies to industrial automation to industrial control and drives, our smart homes and consumer IoT, and even health or personal medical devices. How do we take that real world information and do something intelligent with it? And then, of course, in many cases, communicate that to the cloud. And that is often, of course, done wirelessly, which I'll talk a little bit about in this presentation. But most of the presentation today is going to be focused on the green circle in the center around the software ecosystem. Of course, that includes RT-Thread, as well as the compute and capabilities we embed in our microcontrollers. And I'll talk a little bit about system security as well. I'm pleased to say that Omdia has recognized Infineon as a global market leader in microcontrollers. Of course, it's not all about the chip, and that's why we're here today, right? Is that it is often the software and the operating system that enable developers to get the most out of our product, out of the MCU, and then, of course, get the most out of their product in terms of meeting their end customer requirements. So I'm pleased today to talk about more software enablement through RT-Thread for our expanding portfolio of microcontrollers. Today, I'm specifically going to talk about three families of microcontrollers within my portfolio here at Infineon. First of all, PSoC 6, which is a dual-core, low-power architecture based on Cortex-M4 and M0+. It has software-defined peripherals for custom analog front ends to support last-minute design changes or customize the inputs into the device. Integrated CapSense, which is an industry-leading IP. And then target use cases include things like home appliance, fitness wearables, AR/VR glasses, and other smart home applications. I talked about PSoC 6 a bit last year in this presentation and our enablement within the RT-Thread ecosystem. Today, I'm going to give just a brief update on that enablement. XMC 7000 is our new high-performance industrial control microcontroller. So this is a dual-core M7 MCU with each core operating up to 350 megahertz. It is designed for demanding industrial applications. Of course, it is enabled or supported by differentiating peripherals, including Ethernet and CAN-FD. These devices are SIL2 safety compliant. Target use cases include things here like EV chargers, industrial drive, system control for large appliances, for example, robotics, and HVAC systems. I'm also going to talk about our new product family, PSoC Edge. This is a high-performance MCU family with high-performance domain and an ultra-low power domain, enabling developers to get the best of both worlds. So when their high performance is needed, there is a domain dedicated to that, specifically focused on machine learning, hardware acceleration. And there is a low power domain available as well for things like always-on voice or always-on sensor fusion applications. These devices come with what's known as PSA level 4, which is the highest level of security within that the PSA organization certifies. It enables advanced HMI, And target use cases you can see here, again, AR, VR glasses, a variety of smart home applications, security systems, and beyond. First of all, a little bit deeper on PSoC 6. So again, it's a dual core architecture optimized for power and performance. So it's 150 megahertz Cortex-M4 family, supported with 100 megahertz Cortex-M0 Plus for low power, low bandwidth operations. And this M0 also supports the secure processing domain. It has robust embedded security. These devices, for example, are PSA level 2 security. I believe these were the first devices in the industry to be awarded PSA level 2. They have integrated rich on-chip peripherals to reduce system cost, ultra low power for longer battery life in your platform. And again, as I mentioned on a previous slide, our industry-leading CapSense IP and software and tools support these devices as well. Very versatile as a multi-purpose, multi-capable MCU platform. As I mentioned in my talk last year, we have enabled PSoC 6 in the RT-Thread ecosystem, and these boards are available today. It's a well-designed, low-cost evaluation board with full RT-Thread RTOS support, primarily focusing on IoT applications with connectivity integrated into this solution, and can be easily combined with other third-party modules to expand the capability, for example, for sensor inputs. So again, this EVB or evaluation board is available today through the RT-Thread ecosystem and through Infineon. The XMC 7000, a little bit more detail on this. We have a single and dual core variants of this product based on the Cortex M7. It also has a M0 low power domain as well, where also we have our security peripherals enabled. Up to 105 16-bit and 32-bit timer counter PWM blocks. Up to 11 reconfigurable serial communication blocks. So these can be configured as I2C, UART, SPI, and so on. Up to 220 programmable IOs, multiple ADCs, multiple CAN interfaces. As I mentioned, 10, 100, and 1000 megabits per second Ethernet MAC interface, crypto engine support, of course, different low power modes to support a range of applications. And these devices, what I would say, are industrial ready, so full true 5-volt support for these products across the full temperature range, -40 to 125 C. This product is available now, and the kits are available as well. And here's what I want to show from a kit perspective. So the evaluation kit, where we have this enablement, you can see here, includes, it's really targeted towards industrial applications. So you can see the support here for the high performance MCU, external additional flash memory, even though these devices come with ample on-chip memory as well. And then, of course, ability to integrate or I'll say pre-develop your system with access to the CAN FD and Ethernet ports on these devices as well. There's a handy M.2 connector here available for peripherals, including things like Wi-Fi additions to these boards. So again, it's a modular system with additional enablement through Arduino. You can see those headers on the board, as well as M.2 connectors. The out-of-box experience has onboard debugger and DC power supply provided. It comes with the kit, fully integrated into Moto's toolbox, and now RT-Thread available or support. So ready to go to begin your development. So where are we today in our cooperation with RT-Thread? So we have the kernel adaptation to the kit I just showed. We've had the live streaming of the porting experience already shared on social media. The EVB is available online, and fully accessible. You can see some of the joint promotion we've done here with RT-Thread to promote this kit and make it available, and frankly well supported within the ecosystem. The next thing I want to talk about is the high end of our portfolio. So yeah, you may be thinking, wow, dual core M7 at 350 megahertz, that sounds pretty high end for an MCU, and it is. But I can tell you one of the major trends that we see in the industry is this transition between, I'll say, low to mid-end MPUs running a full-blown RTOS like, a full-blown operating system like Linux, being able to now, that portion of the market being able to be served with high-performance MCUs. And you can see this specifically as many of these applications start to move towards machine learning or AI to do some, if not all, of the processing or the main processing of the application. So this is a market trend that we see. I believe RT-Thread sees this in the industry as well. And this represents an opportunity for Infineon. It represents an opportunity for Infineon within the RT-Thread ecosystem. And it represents an opportunity for developers who maybe today are spending a lot of money to support an MPU because of all the external high performance memories. They have maybe a 10-layer board, so they have a complex power hardware design, including an external PMIC, and maybe even in some cases, because these things are so power hungry, right? Maybe it's a heat sink and or a fan in the system as well. So really expensive hardware design. And if you could do that with an MCU, your hardware design gets much simpler and cost effective. But in addition to that, your software design does as well. So you can move into an RTOS like RT-Thread and and support a lot fewer lines of code. So the family that we have today that is moving up against this into this portion of the market that has traditionally been served by microprocessors is what we call PSoC Edge. So it's a high performance MCU family targeting secure connected HMI and machine learning enhanced sensing and real-time applications. So benefits of this, of course, are increased ML performance, and I'm going to give you a few examples of what that means in a minute. Leading HMI features, reduced system costs, and superior power consumption. We say ML compute ready. There's actually, as I'll show you in a few slides here, there's a low power domain, which has a lightweight neural net coprocessor in there for always on functions. And in the high performance domain, we have a really high performance Ethos U55 NPU for hardware acceleration of neural net as well. Of course, all of our basic enablement comes with these products, including machine learning support. And I'm pleased today to say that we are actively working with RT-Thread, not just to bring the software over, but also to make a really exciting evaluation board for the ecosystem, which I'll talk to in a few slides. So when I talk about the performance of this processor, here I show on the left, of course, there's a range of capabilities. So I'm going to give some examples. So we have PSoC 6, just to put like a stake in the ground in terms of performance. So 150 megahertz Cortex M4, what is it capable of, right? In terms of these types of applications or functions. And then we have what is the E81, which I will tell you from a performance perspective, you can think of that as a M55 with helium DSP extensions running at 400 megahertz. And then you can think of the E83 and E84 where we add the Ethos U55. So to give a few examples, if we look at things like radar, okay, as an example. So we can do people detection using radar on PSoC 6. Okay, so one person walks into the room, can we detect that on an M4 and 150 megahertz and process the point cloud data or the data coming off of the radar sensor? Yes, we can. However, when you do that same kind of people detection on a PSoC Edge, you start to see not just 2 or 3 or 5 or 10 times performance increase. You start to see things like 500 times the performance increase on that radar sensor data processing. So what does that mean from an application perspective? Well, it means you can do it that much faster, which probably isn't so interesting if we're just trying to detect if someone came into a room, for example. Do you need to know it that much faster? Probably not. But you can do other things then as well. It was like you can track the people in the room. You can identify the position of the people in the room. Are they sitting? Are they standing, for example? So you can start to run a lot more complex machine learning models on the device locally than you could on a 150 megahertz M4, for example. Similarly, if we look at audio or voice recognition, I think it's pretty commonly known that you can do what we would call a near field voice. So within a meter, single microphone support of a wake word on a Cortex M4 at 150 megahertz. That's very doable. However, you won't have things be able to support things like echo cancellation and noise suppression and beamforming on that device. If we move to PSoC Edge, however, now you start to get a really rich experience where you can do far field voice detection, not just keyword spotting. Keyword spotting in this case will be done in the low power domain only, but it can do what approaches natural language recognition on the device without going to the cloud. So you start to see a lot richer audio front end in terms of the pre-processing of the environment. So being able to do things like noise suppression, whether that be talking in the background, whether that be wind noise while you're outside, whether it be typing on the keyboard, right? A range of noise suppression can be done locally on the device. And then a full, I'll say, library, even a multi-language library of local voice recognition and near natural language processing can be done as well. So to give you an idea of the range of capability, when we say performance improvement, it's very drastic, going from a Cortex M4, M33 world for these kind of applications up to this PSoC Edge, where we have a 400 megahertz M55 paired with an Ethos U55. So what does this mean? Ultra low power, always on activity detection, unprecedented capabilities in an MCU form factor, as I mentioned. You know, some of these things, if we compared it to an A class, would be like a gigahertz multi-core A class, would be doing this brute force kind of calculations. These devices, because they're able to support the neural nets in hardware, are much more efficient at that. So again, really targeting that area where we start to see opportunity, where traditionally developers have used NPUs to get the performance they need, are now going to be able to get that performance out of MCUs. This is our PSoC Edge. This is what we call the E84. So if we look at it over here on the left, we have M55 plus with the hardware floating point unit, of course, plus the Helium DSP extension. So this is a place where we actually have really strong DSP performance on the M55. We pair that with the Ethos U55, which is a 128 Mac NPU, targeting your ML applications, up to 5 megabytes of system RAM on chip. Additionally, 256 kbytes of instruction and data cache TCMs. I'm sorry, 256 kbytes of ID TCMs. We also have another megabyte of SRAM in the low power CPU subsystem, as well as 16 kbytes of cache paired with the M33. So again, if we look at the high performance domain up here, you can see the M55 and U55 up to 400 megahertz. In the low power domain, it's an M33 paired with what we call NN Lite, which is a very lightweight yet highly efficient neural net coprocessor for the M33. We have a wide range of external memory support and interfaces. They're on the E84 version of the device. There's a 2.5D GPU for really rich graphics support. Of course, we can do things and offer software solutions for local voice, as well as cloud voice, keyword spotting, wake word detection, vision, whether that be Face ID, object detection, object tracking, for example, and then what we call a friction-free interface for safety applications. So a lot of the examples I gave may sound like they're consumer examples, but in actuality, a lot of this also applies to industrial use cases. Rich set of peripherals, serial and communication peripherals. The security on this device is up to 25 Jill points. This is the industry's first PSA level 4 device, as I mentioned earlier. And I will also mention, in terms of the call out specifically here, that these devices support 10100 Ethernet as well. Okay, now I'm going to talk a little bit about the extended support that we offer for PSoC Edge based developments. So we can start with the Infineon Edge AI solution offering, which includes a set of what we call ready models, so kind of turnkey models for various functions, as well as starter models, so models where developers can begin their exploration of machine learning and how that can apply to their application. We also provide a solution for developers called DeepCraft Studio, which is an end-to-end machine learning development solution. You can start with, you have nothing and you want to collect data, take that data, label it, and create a model, optimize that model, and get that then targeted towards to run locally on PSoC Edge. If you have a data set already, you can import that data set and label it there. If you have a labeled data set, that's great too. You can start with that. So really, meet the developer where they are from a machine learning perspective. And the output of the tool, of course, is a .c file for integration into your PSoC Edge application. This tooling supports all of our Cortex-M devices. Of course, today I'm focused on PSoC Edge in this portion of the presentation, but I showed earlier XMC 7000 support as well in PSoC 6, and those devices can have a similar experience as PSoC Edge through our tool chain. In addition, of course, Infineon offers a range of sensors like radar and microphone and other sensors for these sorts of applications, as well as connectivity and dedicated security devices. A little bit more about DeepCraft Studio. So it is a state-of-the-art end-to-end AI development platform. You own your own data, or developers do, and the data is only used to train your models, and the data is stored offline on your machine. So there's a real high level of privacy and security around the data in your model as well. You're not going to be locked into an ecosystem. I know, unfortunately, some suppliers really offer solutions that are only available to support their silicon. We want to make this easy for developers to access this from a solution perspective. It, of course, includes auto ML functionality, so it auto-generates high-performance AI ML models optimized for speed and low footprint, so really targeting MCUs. And then it's really visualization is king, so no more black box. You can really see what's happening in the models that you create, and then tune them accordingly. From a developer flow perspective, you can see this at the bottom. Collect and annotate the high quality data, manage the data in different data sets, build and train great models, evaluate and find the best of those models for your product, and then optimize and package that into your application. One great way that's coming up for developers to get started in this journey is on this new PSoC Edge development kit that we've been partnered with RT-Thread to develop. So we jointly developed a low-cost and highly extensible PSoC Edge development kit with RT-Thread support. So it enables developers to easily start their design for Edge AI products with PSoC Edge. You can see a couple pictures of physically what the kit looks like, as well as the block diagram of the kit already as well, called EdgyTalk. The features, of course, are up to 32 megabytes of HYPERRAM, 5 megabytes of SRAM, plus 512K bytes of RRAM that's on the device, and then 16 megabytes of quad-spy flash external. A display connected through MIPI DSI. It's a 4.3-inch display with the Raspberry Pi interface compatibility. I won't read all of that, but you can see we also have our microphones in this kit, a speaker for audio output, Wi-Fi combo device. This CW or CYW55512 is Wi-Fi 6 plus BTBLE. So really well-rounded IoT kit, and now available with RT-Thread. So this kit will be launched later this summer. With that, I want to say, my expectation is that we have, as Infineon, continue to grow with RT-Thread and participate in the RT-Thread ecosystem. We have another product family new to the market focused on industrial control applications and power conversion called PSoC Control. We're looking at where we launched those devices at the beginning of this calendar year, and we're looking at what the right intersect point for RT-Thread enablement on those products as well. We want to provide an end-to-end customers with turnkey solutions, including the Infineon MCUs and RT-Thread OS and middleware. We want to invite developers like yourselves into the community of RT-Thread to experience PSoC Edge, PSoC 6, XMC 7000, and then as we bring PSoC Control to market within the ecosystem, we'll share that as well. And I guess I'll be back next year talking about PSoC Control enablement in RT-Thread. Jointly sponsor this, of course, with China University Embedded Design Competition in 2026. So really looking forward to continued cooperation with RT-Thread. Thank you all again for your time today. I appreciate your interest in Infineon. Thank you.